In this section, we'll be talking about logarithmic functions, and we start the discussion with the definition that's written over here on this page. We have a new symbol that we're going to be working with. It's going to be called log or logarithm, and we'll talk about what this means. So what does it mean to write down logarithm with the little a down here and an x right there equal to y? Okay, this literally means that I am looking for a power called y that I put on top of the little a to get x at the end. So that's what this notation actually means. This is what we call the definition. Okay, so I'm looking at what power I put on top of the base a to get x at the end. So like for example, if I told you log 3, 9, and I said, what is this equal to? You should be thinking to yourself, what power do I put on top of the 3 to make the answer become a 9 at the end? And you may be wondering, and you may think that maybe the number is 2, because 3 squared would be eventually 9. So basically, when we're working with logarithms, all we're doing is finding powers. Okay, so we're finding the number, and the number is 2 in this case, and that's because the power you put on top of the 3 to get a 9 at the end is the power 2. And if you're wondering why do people care about these logarithms, well, they're super useful in real life. For example, we use them to talk about sound. We use them when we're talking about the earthquake magnitudes. Those are just a couple of applications. But all we're doing in these problems is looking for the power. Okay, so we're gonna practice writing logarithmic notation into exponential notation and vice versa in the next couple of problems. But before I do that, let me talk about some of these guys. Let me give you some names first of all. Okay, so throughout this chapter, you will hear me refer to the a as the base of the logarithm. Okay, so the base of the logarithm is called a. The x that's written right next to the log is called the argument. Okay, so this letter or number, whatever it is going to be called the argument. And y is the solution. It's going to be basically the power of the problem. Okay, so the y goes in the power, the a stays in the base, and the x kind of like goes by itself on the other side. That's what we did down here. We took the 9 to the outside. The base was 3, so I kept it in the base location, and the 2 was the answer, and I put it in the power. Okay, so that's how it's going to work. Now, the first notation that I started with is called the logarithmic notation. The second notation that I started where the word log does not show up is called exponential notation. Okay? So in the first couple problems, what we're going to be doing is pretty much just practicing going from logarithmic notation to exponential notation and going from exponential notation to logarithmic notation. So in this first problem, it says 5 equals to log base 3 of x. That's how we pronounce this. So we say log base 3 of x is equal to 5. The question is, what does this actually mean in exponential notation? Well, again, keep in mind that the base is 3. So I'm going to write that first. 3 is the base. I'm going to think about what the power is, and the power in this problem is 5. I'm going to put that on top of the 3, so 3 to the power 5. And then I'm going to write it down and say that this is all equal to the x. And x was pretty much the argument of the logarithm. Okay, that stays all by itself. Okay, so the x that we're looking for is basically 3 to the power of 5. Okay, so the first notation that I wrote is logarithmic notation. The second one is exponential notation. Okay, how about the next one? The next one says 2 equals to log base 5 of 25. And again, what do we mean when we write all of this language over here, all this notation? We mean that 5 to the power of 2 is equal to 25. So when we write log base 5 of 25, what this part means is that we're looking for a power that we put on top of the base 5 to make it at the end power 2. Power 20, to make it at the end equal to 25. So the base is 5, that's why I kept it there. The argument is the 25, that's why it goes all by itself on the other side. And the power is 2, that's why it goes in the power location. Okay, so the final answer for these problems is supposed to be what's written over here on this side, the exponential notation. And you don't have to actually calculate or do anything, it's just rewrite it and that's it. Okay, and finally -3 equal to log base 3 of 1 over 27. This means, again, follow the same format. 3 to the power of negative 3 is equal to 1 over 27. Now in the next question, example 2, we're going to be going the opposite direction. We have the exponential notation and we want to write it in logarithmic notation. So now we have 5 to the power of x equal to 2 and we want to write it with logarithms. So again, I'm going to try to mimic what we did for the first one. I'm going to figure out where the base is. And in this problem, I see a 5 right here. So that means the base is supposed to be 5. So I'm going to write that down. And I'm going to look for what the power is. The power in this problem is going to be the letter x. And that power is going to be the green thing, which we put on the other side all by itself. Okay, so 5 and then x. And it's equal to what the argument is. And in this case, the argument is just simply 2. Okay, so that goes right next to the logarithm. So log base 5 of 2 is equal to x. This is the same thing as saying 5 to the power of x is equal to 2. So we kind of like push the 5 under the x and it gives us the 2. Okay, that's kind of like how this works. So I double check it at the end by doing this little picture thing to make sure that I did it right. So let's try it out for t equals to w. So pause the video for a second and see if you can answer this question. See if you can get the right solution. So log, and what's the base, what's the argument, and what is it equal to? Okay, did you end up with log base 4 of w equal to t? Hopefully you did. So again, that's the answer, and again, that's the answer, okay? And in this case, we are starting with exponential notation, going to logarithmic notation. So finally, the last one has 7 equals 2 to the power of x. And what does this mean? Again, if it's easier for you, you can rewrite it as 2 to the power of x equal to 7 maybe, so that it looks like the other ones. But in any case, we have log, and then the base is gonna be the 2, because that's what I'm seeing in the base over on the other side. So the base here of the power is 2, so that's why I'm writing the 2. Separately on the other equal sign, there's a 7, so that goes inside the argument. So 7 is the argument, and it's equal to the power, which in this case, the power is the letter x. So there it is. And again, that's the final answer. Okay, to make sense of logarithms in this section, I skipped a little thing over here about the base. The base is again chosen to be greater than 0 and not equal to 1. Again, for the same reasons we mentioned when we were talking about exponential functions. When the base is 0, things are boring basically, because 0 to any power will still be 0 and we don't get anything useful. So if my base is 0 and I write a number over here, then it won't make sense anymore. Similarly, if the base is 1 and I write a number over here, you know, 1 to any power is going to be 1. There's no other number I can write except for 1, and it becomes sort of boring. That's why we avoid the 0 or the 1. And we don't like negative values either, so we're going to stick with the positive amounts.